I hope you have gone through the question. The question is like this: the six group of students of size 3, 1, 6, 4, 5 and 2 need to fit into minibuses with capacity 7. We have to find the number of buses needed to pack them efficiently. So this is a bin packing algorithm applications. So 4 things we should know to perform the bin packing algorithms. The 4 things are: the first one is the lower bound. The first one is lower bound. The second one is first fit. First fit. First one is lower bound, second one is first fit, and third one is the first fit decreasing. First fit decreasing. And the fourth one is the full bin packing. Full bin packing. These are the 4 things we need to remember. That means the first one is that how to find lower bound for the problem. Second one is that how to perform the fast fit algorithm. Third, how to perform the fast fit decreasing algorithm. And last one is how to find or how to perform the full bin packing algorithms. So let us divide this problem into 2 parts. First one is group, is given groups. We have how many groups? One group of size 3, then 1, then 6, then 4, 5 and 2. These are group size. Okay. Now we know that the minibus size is 7. The minibus size is 7. So let me draw a diagram of size 7. 1, 2, 3. So the bus having 7 seat, the size is 7. The first bus 1, this is bus 1, then bus 2, this is bus 3, and this is bus 4. Okay, look at here. There are 4 buses I have taken, each bus minibus having size 7, and we have group like this. So first step is that we have to find the lower bound of this problem. So how to find the lower bound of the problems? To find the lower bound, let us add the number of students. The total number of students is 3 plus 1 4 plus 6 10 plus 4 14, 5 plus 2 7 is 21. Total number of students is 21. Total number of students is 21 and each minibus of size is 7. So lower bound, remember, lower bound is equal to number of students, that is 21, divided by 7, that is equal to 3. So the lower bound is 3. It means that the optimal solutions, that means I have to find out the number of buses need to pack them efficiently. So the minimum number of bus required is 3. We can have more than that one also. The lower bound is 3. We cannot go below that one. Okay. Now second one is we have to perform the fast fit approach. Fast fit algorithm. The fast fit algorithm says that it is very simple, and it take each group size and put it to the vacant buses. That means suppose first group is 3. Okay, so in the first bus I have to accommodate them. Let the students accommodate here, the 3 students accommodate here. Okay, remaining 4 seats are vacant. So these 3 students have been occupied. Next is 1, so it is vacant in the first bus. I am allocating here. Next is 6, third one is 6. Now since the first bus there are only 3 seats remaining, so I cannot accommodate the group of size 6. I'll go to the second bus. Let us apply there 6. The second bus, 6 students have been occupied. Okay, so 6 occupied. Next one is 4. So group 4 cannot be accommodated in minibus 1 because 3 seats lying vacant. In second bus only 1 seat lying vacant, so we'll go for the third bus. So third bus, 4 seats occupied. Okay, now 5. Next group is 5. For 5 again bus 1 is not vacant. To accommodate 5, bus 2 only one seat is left behind. In bus 3 only 3 seats left behind. I go to the fourth bus. So here I am accommodating 5 students. Okay, now the final group, that is number 2. I'll go to the first. 2 is vacant, so here I am accommodating 2. So this is the way the entire group 21 students have been accommodated in 4 buses. But look at here, the solution we have got. The number of buses required is 4, but the number of seats vacant here is 1, next one is 2, next one is 3, next one is 2. So 3, 2, 5, 6, 7. So in first fit approach, 4 buses required, with 7 seats vacant or unused. 4 buses used and 7 seats vacant. Got it? Now we'll go for the fast fit decreasing, second approach. Fast fit decreasing. In fast fit decreasing, we have to arrange the groups. We have to arrange these groups in the decreasing order. 3, 1, 6, 4, 5, 2. I have to write them in the decreasing order. Let me write it. Decreasing order. First 6, then 5, equal to group size 4, then 3, then 2, then 1. Okay. Now 6 students. First 6, the size is 6, first group. So they will be allocated here in the first minibus. So all those 6 students have been allocated here. Next 5, only 1 seat is lying vacant there. So I'll go to the second bus. So I am allocating 5 students. 1, 2, 3, 4, 5. Now 4, 6 is over, 5 is over, then come to 4. 4, no vacant in bus 1 and bus 2. I'll go to third bus. 1, 2, 3, 4. Next come 3. There is only 1 seat lying in vacant in minibus 1. In minibus 2, only 2 seats lying vacant. But in minibus 3, 3 seats are vacant. So I am putting there. Okay. So bus 3 is full now. Now group size 2. I'll go to bus 1, only 1 seat. Bus 2, fortunately 2 seats are available. So I am accommodating that one. And last one is 1. So 1 seat is left in minibus 1. I am putting it here. So all the students have been allocated, but 3 buses required. Look at here, and no seats lying vacant. So this seems to be optimal one. So in fast fit decreasing, we need 3 bus and 0 seat vacant. 3 bus and 0 vacant. Lower bound was 3. In fast fit, 4 buses required and 7 seats lying vacant. In fast fit decreasing, 3 buses with 0 seats lying vacant. And last one is your full bin packing. So in full bin packing, what we have to do here, let me remove these seats. we have to arrange the groups in such a that the groups should be equal to the minibus size. So I have to combine these groups. So let us say the first one is 6 and 1. 6 and 1 here I am combining it as 7. Why 7? Because the minibus size is 7. So I am combining two groups, one group of size 6, another group of size 1 as 7. Similarly for 5 and 2, they will be left for one group, second group, and third one is the 4 and 3. So all the students are there. So first 6 1 7. So first bus is full. 7. Second one 5 2, it is also full 7, and third one 4 3, it is also filled. So in full bin packing we have got the same result. That means 3 bus required and 0 seats lying vacant. So among these three solutions, fast feed decreasing and full bin packing, which one is better, which one is optimal? In this particular example, since the lower bound is 3, so we have got in the fast feed 4 buses, but in the second approach, that is fast feed decreasing, here 3 buses with 0 seat lying vacant, and in full bin packing 3 buses 0 seat lying vacant. So that means last two approach gives us optimal solutions. Okay. Now we'll go for another example.